This video is about identifying, writing, and graphing direct variation, and it's lesson 56 in your book. So let's talk about what is a direct variation. Now, when an equation has one variable that is equal to a constant times another variable, this is a direct variation. So direct variations typically look like this. They have their dependent variable, and it's equal to some number, k, times the independent variable. And k is a non-zero constant, and it's called the constant of variation. Basically, it's the number that you're multiplying by the independent variable. And this shows a direct variation. So when we have an equation and we want to know, is it a direct variation, our equation needs to take this form, y equals some number times x. When we have a graph and we want to know if it's a direct variation, we're looking for a line that always passes through 0, 0. Because if x is 0, then it doesn't matter what you multiply it by, your answer is still going to be 0, or your y is still going to be 0. Or we're looking for words like y varies directly with x, or y is directly proportional to x. So varies directly and directly proportional are clues that you have a direct variation. Here we want to identify a direct variation from an equation. And they're asking us, does this equation represent a direct variation? And if it does, find the constant of variation. Now what they're wanting to know is, can we put this equation into the form y equals kx, or y equals some number times x? Now this equation definitely isn't in that form, because y is not by itself. So we have y plus 8x equals 0. And if we want to get y by itself, we're going to have to subtract 8x from both sides. Now that gets us y equals negative 8x. Now it's in y equals kx form. So we have y equals some number times x. That tells us that it is a direct variation because we have our dependent variable equals some number times our independent variable. So that is a direct variation. Now, the rules for direct variation equations are you can't be adding anything onto the end or subtracting anything. Can't be dividing by x or dividing by y. It has to be, you have to be able to put it in exactly this form. Y equals some number times x. And then we want to know, what is the constant of variation? So to find the constant of variation, you simply look at what are you multiplying by your independent variable. And in this case, we are multiplying x by negative 8. All right, let's try another one. Here we need to know, does this equation represent a direct variation? And if it does, find the constant. Now, in order to figure out if an equation represents a direct variation, we want to be able to put it into this form, y equals kx. Excuse me. So I need to get y by itself. Now here I have y divided by 10 equals x, and I need to get y by itself. Since I'm dividing by 10, to eliminate that division, I can multiply by 10. And I have y equals 10x. Now since this equation is in this form, y equals some number times x, then it is a direct variation. And to find the constant of variation, we simply look at what number are we multiplying x by to get y, and k is 10 because we're multiplying x by 10. Finally, let's try one more. Does this equation represent a direct variation? And if it does, find the constant of variation. Now we want it to be able to put it in y equals some number times x form. So here we've got x times y equals 6. To get y by itself, I'm going to have to divide both sides by x. So I've got y equals 6 divided by x. This is not in y equals kx form. It doesn't say y equals some number times x. So this is not a direct variation. Sometimes we don't have an equation to check for direct variation, so another way to decide if a relationship is direct is to check whether the ratio of y divided by x is the same for each ordered pair except where x equals 0. Because remember, where x equals 0, y definitely has to equal 0, and you can't divide by 0, so y divided by x wouldn't make any sense. So if you're looking to see if you have a table or a set of ordered pairs is a direct variation, you divide each of your y's by their corresponding x's. And if you get the same number every time, that is considered a direct variation. So here we're going to tell whether this set of ordered pairs is a direct variation. It will be if we divide y by x and we get the same number every time. So for this first pair, I'm going to take y, negative 14, and divide it by x, which is 2, and that gets me negative 7. Now I'm going to do it for the next ordered pair. I've got negative 35, which is my y, divided by x, 5, and I get negative 7. Same thing. Now if I take my y here, 21, and divide it by my x, negative 3, I get negative 7. So since we are dividing y by x and getting the same number every time, this is a direct variation. Now let's try another. We want to tell whether this is a direct variation. So we're going to take each pair and divide y by x, and if we get the same number every time, it's direct, and if we don't, it's not. So here we've got 4 divided by 2. 4 divided by 2 is 2. For the next ordered pair, I've got 5 divided by 3, and 5 divided by 3 is not 2, it's actually 1 2/3, or 5/3. So since we divided y by x and got 2 different numbers, this is not a direct variation. Sometimes we need to write a direct variation equation given a point. So in order to do that, we have to figure out what is our constant of variation. Here we want to write an equation for a direct variation that includes the point 6, 24. In order to figure out what k is, we are going to use our direct variation form, y equals kx, and sub in the point, or the x and the y value. So we've got y equals kx, and we know that x is 6 and y is 24, so we'll plug those numbers in. And then we'll solve for k. So here I've got k times 6. I want to divide both sides by 6. And that tells me that k is 4. So to write my direct variation equation, I'm going to use my general form, and I'm just going to plug in my number for k. So it's y equals 4x. Here we want to write a direct variation equation, and then we also are going to need to use that equation to solve a direct variation. Here, the distance a person runs varies directly with time spent running. If a person runs 12 miles in 2 hours, how many miles will the person run in 3 hours? Now, this sentence here tells us how to create our equation. The distance a person runs and the time spent running are our variables. Now, since the distance they run depends on the time, distance is going to be our y. And since time is independent, that's going to be our x. So we have a point here. They run 12 miles, that's their distance or their y value, and the time it takes is 2 hours. So we have time 2 hours, distance 12 miles. And we need to create a direct variation equation for this. So we need a y equals kx. Now I know in this point y equals 12 and x equals 2. And to solve for k, I'm going to have to divide both sides by 2. So 6 equals k in this direct variation equation. So my direct variation equation is y equals 6x. Now the question is, how many miles will the person run in 3 hours? So I'm looking for a distance, y, under a given time, 3. So I plug that 3 into my x value, and I get that y equals 18, or that in 3 hours they will run 18 miles. Now here in our very last example, we're going to graph a direct variation. This says that the grocery store sells 3 pounds of lemons for $1. Graph the relationship and then use the graph to estimate the cost of 12 pounds of lemons. So we're going to start with the point 3, 1. So 3 pounds of lemons, so our x-axis is lemons, and it costs $1, so our y-axis is going to be cost. Now we're going to graph the point 3, 1. 3 pounds of lemons cost $1. Now we know 0 pounds of lemons is going to cost $0. And then we're going to create our graph based on those 2 points. Now we want to use this graph to estimate the cost of 12 pounds of lemons. So if we extend this just a little further, we can see that 12 pounds of lemons is going to be right about here, or right about $4.